Welcome to Tech Talk. Today we'll be talking about a 499 a thesis project at North-South University, Dhaka, Bangladesh. This is a project using Raspberry Pi. As we all know, Raspberry Pi is a new technology in town. It's not really a new technology, but it's basically we fit an entire computer into a 6-inch square board. So we'll be talking about how we can make a surveillance rover using Raspberry Pi. So basically what's happening is we have a camera that's retrofitted to a Raspberry Pi, and then we place the Raspberry Pi on top of a toy car, and the car along with the video feeds will be streamed back to a client computer via a server, which is hosted somewhere in Japan. And this server in Japan is our cloud server. We've written a few programs, and that's about it. So we'll be showing how the entire process works. And basically, I have two of my thesis students here, Tanzir and Nazmul. They'll be going through the entire presentation. We have another person who made the Android app, the Android client app, Sajjad, but unfortunately he's fallen sick, so he'll not be here, but we'll be explaining a bit about the whole project. So I'm handing it over to the guys, so they'll be taking it over from here. Okay, so the person who's going to talk now is Tanzir Kobi. So go ahead.
Okay, hello, my name is Tanzir, and first of all, is basically an application of Internet of Things. And first of all, I'd like to tell you what the Internet of Things really is. It generally describes a scenario where you have various types of devices and sensors and also modules from the real world, and they're all connected to the internet. So what's the use of all this interconnectivity of sensors and devices? What we can do is we can monitor the states of these sensors using tools. And these sensors can also provide some real-time data that we actually need in various environments or purposes like temperature, humidity, or air quality data. And here is a brief overview of the IoT architecture, starting from sensors, connectivity, and network layer at the very bottom. On top of it, we have the gateway and network layer. And on top of that, the management of the whole service with our application layer laying on top of it all. And here are just a few examples of IoT applications, like baby monitor using a sensor, and making an app to remind to take your meds, or to monitor an aging family member residing in a nursing home, or a smart daily trash, which is basically a smart trash can. And here are the various requirements for implementing a smart environment in different scales, starting from small scale to medium to large. So now I'll be talking, starting to talk about the project a little bit more, starting with the project background. We are basically making a surveillance rover, mini-rover, and the purpose of surveillance comes from providing security. Like security plays a pivotal important role in our modern life, and that security we can use remote surveillance, and it can be very effective as well. In currently, present day, surveillance systems that we are provided are actually fixed point CCTV views. So what they do is we record and obtain surveillance footage using point-kill zoom CCTV cameras, and these are actually very costly. and also they remain fixed at one single point. So they can't actually roam around and provide coverage for a larger area. So that's why we chose to build a mini rover, which can actually move around. And our aim is to actually develop it as a low cost and a real-time video surveillance mini rover. And it will be capable of giving us real-time video footage and also roam around in the area which we want to observe. And the hardware that we will be using has to be very low of cost and also easily available in the market. So here are the main salient features of our project one by one. First of all, it should be inexpensive in comparison to the currently available present surveillance equipments. It has to be cheaper than the ones available now, like the CCTV cameras that we get now are always around $100 to $450, depending on the company. And the Mini-rover's chassis should also be able to move forward, backward, left, right in all directions on its 4 wheels with all the equipment on board. The US webcam that we will be using should be able to provide with a clear real-time view of the area in front of it. And the video stream data that we get from the webcam should be sent to the remote controlling platform over the internet or over the wireless network so that we can display it to the users of our screen. And the mini rover should be able to receive commands from controlling platform. Either it's from a desktop or a laptop over the internet or wireless network, and also move around according to those commands that we give. And lastly, the system should be easily modifiable so that if we want to add something in the future, like if you want to add sensors with the video surveillance module, then we need to be able to do that. So we need to build it in that way. So here's a brief overview, outline of our project. In the middle, you see that the server with a public IP or server in the same local network. And our Raspberry Pi is actually connected to the server, and the user or client, PC or Android device, where the Raspberry Pi, the mini rover will control from by giving those commands to the platform, is also connected to the server. And with the Raspberry Pi, for controlling it, we connected to the Raspberry Pi. To get the video, we need a use webcam and an internet connection to the Raspberry Pi. We also need a Wi-Fi pocket router or a Wi-Fi adapter. So now I will be one by one describing the hardware, the list of hardware that we use for a mini rover. First of all, the brainchild or the brain of our whole mini rover is the Raspberry Pi 2. This is the choice of processing machine for our mini rover, and it will be responsible for all the image capturing, processing, and streaming, while also controlling the movements of the rover. Some specifications of Raspberry Pi 2 briefly. It's very low cost, and it's a full-fledged yet credit card size computer. It costs only $35. It has a quad-core processor with 900 megahertz ARM Cortex A7 CPU with 1 gigabyte of RAM with 40 GPIO input-output pins. And the operating system that it runs is called Raspbian OS. It's an optimized version of Debian Linux for the Raspberry Pi. So why did we choose Raspberry Pi 2 as our main processing unit for our mini rover? First of all, it doesn't require much power and it's very low cost. It also runs on a readily available Raspberry OS, which is optimized for the Raspberry. The number of GPR pins that it has, a total of 40. You can connect all kinds of sensors, modules, necessary modules. And even after what we needed, the very few GPR pins that we needed, we still had a lot of them left so that we can make future modifications to our Mini-rover. And it's a full-fledged CPU capable of connecting to local net through its Ethernet port or using a compatible USB modem or USB Wi-Fi adapter. Next of all, for controlling the Mini-rover, we have a dual motor controller called the L298N H-bridge. It's a dual motor because our Mini-rover is driven by two small DC motors, one in the front to drive the Mini-rover in the forward and backward direction, and the other one in the rear that makes the rover go left and right. And to activate and deactivate those, we need to, and also to control the direction, we used this motor controller. To capture video footage from the Raspberry Pi, we used the standard USB mini webcam. It's plug and play, A4 tech, and it only cost just under $13. To provide power to the Raspberry Pi, we used 4400 milliampere mAh FSR mobile power bank. This is also very standard and also plug and play. Now the chassis for the Mini-rover that we use is actually salvaged from a thrown out four-wheel RC toy car chassis. What it had a Bluetooth RC module, and we replaced that with our dual motor controller that we use. And we placed all the other components on top of that on the chassis. Now, Mohammed Hussain will be starting off with the project software for Mini-rover.
Mohammed Mazmoon Hussain, and I'll be talking about all the softwares that we use in our project. So, in line of that, first comes the Raspbian operating. It's an open source operating system based on Debian Linux, and as Tanzir has already told, it's an optimized version for the Raspberry Pi series, and it's available for downloading at the link shown in the screen. And basically, what we did was downloaded the .iso file, that's the disk image from that link. Then we, with the help of a disk imaging software, we wrote the image file on a micro SD card, and in turn that micro SD card was inserted into the Raspberry Pi 2 that we used in our Mini-rover. The Raspberry Pi can boot using that Raspbian operating system. So next, and here you can see in this image, it's a standard desktop environment of Raspbian operating system. Next comes Python. As all of us know, it's a very popular programming language used in the project for communicating with all the hardware that are connected to the Raspberry Pi on board the Mini-rover. Both our motor and obtaining the video data was done using two Python scripts. Those ran on the Raspberry Pi 2. Also used Python socket programming at the Raspberry Pi 2's end for exchanging the data with the central server. The central server can be either a cloud server with a public IP, or it can be a separate laptop or desktop running the server program on the same where the Raspberry Pi and client is connected. Next is OpenCV. OpenCV is short for Open Source Computer Vision. It lies at the heart of our video capturing and streaming process. It contains numerous built-in functions like any kind of image or video file. Accessing and extracting individual frames from the webcam that is attached at the front of our Mini-rover was done using a Python script named capturetest.py running on the Raspberry, which used some OpenCV functions, OpenCV library functions to obtain the video feed and then stream back those byte array. And also on the control laptop, that's the remote control laptop, which will be controlling our Mini-rover. All the programs running on them are written and implemented using Java. And a data movement control application on the control side, that's on the client side, was achieved using Java GUI programming. So after Java, there is SSH, Party, and Xming. SSH stands for Secure Shell. It's a protocol for remotely accessing any Linux desktop. So Xming and Party, these are both third-party softwares to remotely access the desktop environment of the Raspberry Pi 2 that is on board the Mini-rover. Next is our project setup and implementation. Here we will be talking about how we set up all the hardware and software to successfully implement our project. So first comes the assembling all the hardware. So with all the major components already described in part 4 of the project hardware, we also used some miscellaneous items to assemble all the components to put them all together. So first what we did was we used a protective plastic casing for Raspberry Pi 2, so from outside disturbance or it's not damaged by external forces. We did the connection, we provided the connection between the Raspberry Pi 2's GPIO, that general purpose input-output pins, motor controllers, that is our motor controller that we use is L298M. We provided the connection between the Raspberry Pi 2's GPIO pins and the motor controller's input pins. And these connections are shown in the next slide. As in this image, on the left-hand side, there is a Raspberry Pi 2's GPIO diagram, and on the right-hand side, you have the motor controller. And the battery here is representing the external power source for providing power to the two DC motors that will be driving, that will give motion to our Mini-rover. On the right hand side, you can see there is output A and output B. Output A is connected to the rear motors terminal, and output B is connected to the front motors terminal, which is both of these two motors are on the Mini-rover. So basically, the rear motor will be driving the rover up and down, that is forward and backward, and the front motor driving the will direct the Mini-rover towards right or left. After connecting the two DC motors of the chassis with the motor controller and then the motor controller with the Raspberry Pi 2, we connected the USB webcam and the pocket to the Raspberry Pi's USB ports. We then put all the connected hardware so far on a salvaged toy car chassis that already Tanzi showed. As shown in the pictures on the next slide, we are also showing the toy car chassis on the next slide. We connected the power bank with the Raspberry Pi 2 at the last stage of hardware assembly to boot up the Raspberry Pi 2. So here you can see on the left hand side is a top view of all the hardware assembled together, and on the right hand side you have a lateral view of the Mini-rover. And now comes running all the softwares. After powering up the Raspberry Pi 2, we established SSH session from a remote laptop using an Ethernet cable, PATI and Xming server. After that, we opened console on the Raspberry Pi 2 using the SSH session, and then we obtained privileges. After that, we run the central server program, that is main.java, on a separate laptop, which is connected to the same Wi-Fi network provided by the pocket router connected to the Raspberry Pi 2. From the previously opened up consoles on the Raspberry Pi 2, we now access the two Python scripts, and capture test.py, edit them by putting the central server IP address in both those two scripts, and finally by running them, we connect the Raspberry Pi 2 of the Mini-rover with the central server. One thing is to note here is that if we use a cloud server with a public IP, we don't need to edit every time we start the Raspberry Pi. We just put the public IP of the cloud server in the scripts. That will be all. But then we connect the control laptop, that's the client, with the same Wi-Fi network where the central server and the Raspberry Pi 2 are connected, and then run two Java programs that we wrote to control the movement of the Mini-rover in the video footage. And on the next slide, there is an example showing how the GUI for controlling the GUI for the rover control and the video frame panel are. So on the right hand side, you can see the video screen and the video footage sent by the servers, sent by the Mini-rover. And on the left hand side, a rover control screen. There are just 6 buttons: up, down, left, right. If you press up, down, or left, right, the rover accordingly. If you press straight, the rover will go straight, and if you press stop, the rover will stop moving. Besides programs, with the help of our advisor Tarifriyat Rahman and one of our fellow NSU students, Sajjad Hossain, Android application was developed which could control the Mini-rover and display the video feed on the Android devices screen. So now to explain a little about how we developed the Android application, here is our advisor, Mr. Tarifriyat Rahman.
So this is the Android app that was used for this project, and this is Hossain's work. Unfortunately, he's not with us here as he is ill. He's caught a cold. So I'll just go through in general how this app's. So basically in this slide, we can see there's a lot of technical details, but we'll not get into them deep. In general, it's just a client that Nazmul and Tanzi just showed us a little while ago. The app contains 5 buttons, basically left, right, up, down, and stop. And behind the buttons in the background, the video stream frames are viewed on the camera. So the camera works in such a way that the user can press the controls at the same time see the video feeds from the Raspberry Pi driven card. And yeah, that was pretty much the Android app. And so I think the last phase will be explained by Nazmul, the limitations and their future plans in regards to this project.
So like all other things, our project has also some limitations. So as we used a very simple RC tracker chassis, due to as our budget was very limited, our Mini on a hard and solid surface. But in case of muddy or sandy terrain, our Mini-rover init is not suitable. However, if a stronger, robust chassis with greater mobility is designed and used with our Mini-rover's concept, that will be able to handle terrain quite well. And due to its current RC Toyota chassis, our Mini-rover can take any extra payload. But this limitation can be overcome easily by using the solution described in the previous point. And the third limitation is the viewing angle of the USB webcam is currently fixed. If someone wants to obtain a different viewing angle, so he has to basically move the Mini-rover in the desired direction. So now the feature works part. For our feature work on our project, we can modify the Mini-rover chassis so that it can handle all kinds of terrain and all kinds of inclement weather. Then we can add any necessary sensor on the Mini-rover. That is, we can add a digital temperature and humidity sensor, or gas sensor, air quality sensor, or sonic sensor for measuring distance to obtain the necessary information. And the third point can be we can add a solar panel and compatible battery modules on the modified rover chassis, so that it can be solar powered and self-sufficient. So it once it's solar powered, you don't need constant the batteries, the power banks on will not be needing constant recharging. And the last part is our Android app was developed at a very last stage of our project. There are some minor bugs remaining. Those needs to be fixed, but those are not very major bugs. They are very minor ones.
Okay, so doing the demo on a separate video, and on behalf of Nazir and Sajjad and me myself, Tarif, thank you for hearing us out.